11.7, events involving and conditional probability. Two events are said to be independent events if the occurrence of either of them has no effect on the probability of the other. So, for example, if we're tossing a coin, if we toss it 2 times in a row, the probability of landing on heads the second time is the same no matter what we landed on the first time. So those would be independent events. So if you are talking about the probability of 2 independent events happening at the same time, so probability of P and B, then to find that probability, then you find the probability of A and you multiply that with the probability of B. So, for example, if we have a single die and we're going to roll it twice, we want to find the probability of rolling a 5 the first time and a 1 the second time. So I'm wanting to find the probability of 5 and a 1. So first, the probability of a 5. There is one way to roll a 5 out of 6 ways to land for a die to be rolled. The probability of landing on a 1 is also 1/6. So the probability of a 5 first and then a 1 would be 1/6 times 1/6, which is 1/36. Okay, so let's find the probability that we land on an odd number the first time and then a number less than 3 the second time. So I'm looking for the probability of an odd number, then less than 3. Okay, so the probability of an odd number, well, we could land on 1, 3, or 5. So there are 3 possibilities out of 6. So that probability is 1/2. Now the probability of landing on a number less than 3, well, we could land on 1 and 2. So there's 2 ways to do that out of 6. So that probability is 1/3. So the probability of landing on an odd and then on a number less than 3 would be 1/2 times 1/3. So that probability would be 1/6. Okay, so let's say that you draw 1 card from a 52 card deck. Then the card is replaced in the deck is shuffled, and then you draw again. Find the probability of drawing, so on. First of all, the fact that this is replaced and that the deck is shuffled ends up being quite important, and I'll come back to this later. Okay, but for right now, we want to know the probability that we draw a picture card the first time and then a heart the second time. So the probability of drawing a picture card, so out of the 52 cards, there's the Jack, Queen, and King of 4 different suits, so that would be 12 picture cards. 12 over 52 reduces to 3/13. Now the probability of drawing a heart, there are 13 hearts out of the 52 card deck, so that would be 1/4. So the probability of drawing a picture card and then a heart would be 3/13 times 1/4, which would be 3/52. Okay. Let's find the probability of drawing a jack the first time and a club the second time. Probability of drawing a jack. There are 4 jacks in the 52 card deck. So that would be a probability of 1/13. The probability of drawing a club. There are 13 clubs in 52 card deck, which is 1/4. So the probability of drawing a jack and then a club would be 1/13 times 1/4, which would be 1/52. Okay. So let's say a coin is tossed and then a die is rolled. Find the probability of getting a head and a number greater than 4. So the probability of tossing a head, there's, of course, the sample space is 2 because there's heads and tails. So there's one way to do this out of 2, so that probability is 1/2. The probability of rolling something greater than 4, well, that would be 5 and 6, so that's 2 ways out of 6, which is 1/3. So the probability of tossing a head and a number greater than 4 would be 1/2 times 1/3, which is 1/6. Okay, so now let's do the probability of a tail and a number less than 5. The probability of throwing tails is 1/2. A number less than 5, that would be 1, 2, 3, 4 out of 6, which is 2/3. So the probability of tails and then a number less than 5 would be 1/2 times 2/3, which is 1/3.